In this video, we want to consider important ideas in senior SMO, Singapore Mathematical Olympiad, orders, trigonometric formulas, derivative and Lagrange multiplier, binomial theorem, these 10 ideas, and we will solve related problems from AMC, American Mathematics Competition, BMO, British Mathematical Olympiad, SMT, Stanford Math Tournament, and HMMT, Harvard, MIT Math Tournament. We want to focus on these 10 ideas. I will tell you some of them, and you can do the rest as homework. First, for example, these problems that we have, I can say most of the years of senior SMO, orders of some numbers. The next idea is related to trigonometry. You should memorize important formulas related to trigonometry, this problem from AMC. And then derivative and Lagrange multiplier for the problems that you should find maximum or minimum of something. These two problems from senior, three problems from senior SMO. And binomial theorem, two problems from senior SMO, last senior SMO, and one problem from AMC 2021. The next one, two ideas, important ideas when you see square root. Next one, divisibility and modular, that is important in senior SMO, and also related problems from AMC. The next one, quadratic Vieta's formula and Newton's sum. One problem from senior SMO, one problem from AMC 12A, one problem from SMT Stanford Math Tournament. Next one, important identities that you should know. And casework and counting, which is so much important in all three parts, junior, senior, and open section. We will solve problems from senior SMO. I think this problem is for senior SMO 2021. And also this one from senior SMO 2021. This problem from Harvard MIT Math Tournament, HMMT 2023. And this problem is from, it's for AMC, last AMC, in both 10 and 12A 2022. And then a small example, which is so much useful. I solved many problems with this idea in senior SMO. We can use that. And also in AMC and BMO 1. It is the last idea. Okay, first idea, order. When you see problems like this, and you want to consider, for example, the order is what we had also similar problem in BMO, British Mathematical Olympiad, you should consider 2 by 2. For example, this number and this number. First, let's see which of them is greater. And when you have 6, the index is 6, you can say it is 1 over 333 to the power of 1 over 6. And you want to consider this with 1 over 18 to the power of 1 over 3 because it is cube root. Now you should do something to have equal base or equal power. For this part, I raise both of them to the power of 6. So it will be 1333 to the power of 6. And this one will be 1 over 18 to the power of 6, which is here it will be what? 1 over 18 to the power of 2 squared. So 1 over 324. Now, which of them is greater? 324. If we cross multiply because they are positive, we can do that. Here it is greater, greater, greater. So we understand that this number is greater. So we can't reject this. We can reject this one. We can reject this one. And now we should consider between A and D. So we can consider 1 over 7 and 1 over 18. 1 over 18 to the power of 1 over 3 and 1 over 7 to the power of 1 over 2. We raise both sides to the power of 6. It will be 1 over 18 to the power of 2 and 1 over 7 to the power of 3. It will be 1 over 324. And this one will be 1 over 343. 7 times 49 is this. Now we will see 343 and 324. This one is greater, so this one is greater, so this one is greater, and this one is greater. Okay? So between these two cases, 1 over 18 is greater than that. So we reject this case. 1 over 18 is greater than 1 over 7. 1 over 18 is greater than this. Because we have one choice that says none of the above, so we should check which numbers. 1 over 7 and 1 over 7. Power of 1 over 2 and 1 over 333. The power of 1 over 6. Now we raise both of them to the power of 6. It will be 1 over 7 to 3 and 1 over 3 to the power of 1. Okay. And we will see it is equal to 1 over 343 and 1 over 333. So it is general idea, and which of them is greater? We can say 343 is greater than 333. So this one is greater, this one is greater, this one greater, this one greater. So we understand that this is greater than this, and the answer is D. But let me tell you, because here the numbers and the powers 1 over 2, 1 over 6, 1 over 3 are related, you could do something. You could raise all of them to the power of 6. Then we had 1 over 7 cubed, 1 over 333, 1 over 18 squared. And it will be 1 over 324, and this one 1 over 343. Because this denominator is greater than this, so this one is less than this, and also this one less than this, and you can easily find the answer. But in some problems, it is solution 2. That is so much easier. It is solution 1. Why I've told you solution 1? Because in some problems, the powers are not so much related to each other. And if you want to solve that in one step like this, it will be so much hard. So you should know both solutions. Okay, for trigonometric formulas, we have these two problems here and three problems. Third problem is from AMC. Let me tell the important formulas. Okay, let's start from basic formulas. Sine A, or let's write sine x plus y, equal to sine x cosine y plus cos x sine y. And the next one, cos x plus y equal to cos x cos y minus sine x sine. Also, you should know, for example, sine pi minus x is sine x, but cosine pi minus x is negative cosine x. Sine pi plus x is negative sine x. Cosine pi plus x equal to negative cos x. And some formulas like this, for example, sine pi over 2 minus x cos x, and so on. Lots of formulas. Then you should know how to change product to sum and sum to product. Okay, next formulas are sine x or sine a cos b equal to 1/2 sine a plus b plus sine a minus b. Next one is cosine a sine b equal to 1/2 sine a plus b minus sine a minus b. Next one is product of two cos a cos b equal to 1/2 cos a plus b plus cos a minus b. And last one is sine a sine b equal to negative 1/2 cos a plus b minus cos a minus b. Or you can say cos a 1/2 cos a minus b minus cos a plus b. You can say this one, or let's write, it's better to write like this one. 1/2 cos a minus b minus cos a plus b. Okay. Now for next part. Okay, similarly you can change, for example, sum of cos to product. If we have, for example, cos a plus cos b, you say 2 cos a plus b over 2 times cos a minus b over 2. It's not important you write a minus b or a plus b, because we know that cos alpha equal to cos negative alpha. But for sine, it is negative of that. Now, for example, if you want to calculate sine A plus sine B, then it will be 2 cos A minus B over 2 sine A plus B over 2. Okay. And for tangent also, you know that you should know tangent alpha plus beta equal to tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. Okay. Okay, fifth problem of senior SMO 2022 last year. It says suppose sine 180 plus x equal to this. X is from here to here. Find sine 2x. So sine 180 plus 2x, you can also consider trigonometric circle, unit circle. So when we have 180 plus x, then it will be something like this. For example, if x is this, if you add 180 to that, so it is x degree, and here is 180 plus x. And sine and cosine are negative, so we can say minus sine x here equal to negative 7 over 9. And if you multiply by negative 1, sine x equal to 7 over 9. And sine x is this. And then the problem says x from 450 to 540. So let's consider 450 to 540. We know if we subtract 360, all things will be same. So if you consider subtraction, this minus 360 will be 90. X is from 90, and if you subtract 360 from here, it will be 180. So it will be on this part, 90 to 180. And here, sine positive, cos negative. And when it says find sine 2x, I told you sine x plus y is sine x cos y cos x sine y. If you use this formula, sine 2x will be 2 sine x cos x. Sine 2x will be 2 sine x cos x. So it will be 2 times 7 over 9. And cos x is what? Because it is here is negative, cos, we know cos squared x plus sine squared x is 1. So cos squared x is 1 minus sine squared x. It will be 1 minus 7 over 9 squared. And it will be 81 minus 49. So it will be 32 over 81. Now cos x will be negative square root of 32 over 81, and here it will be negative 4 root 2. I'm sorry, square root of 81 is 9. Over 9, so it will be negative 4 root 2 over 9. And it will be negative 8, negative 56 root 2 over 81. Okay, negative 56 root 2 over 81. It is E. Okay, for this problem, I released solutions of senior SMO 2022. You can use my videos. I solved this with exactly the formulas we have. For AMC, let's solve this problem. Okay, here we want to calculate this. We know sine 3c, sine 3c we can cancel. Then 6c. Let's see the angles. 6c will be what? Will be 12 pi over 11. Times 9c will be 18 pi over 11. Times 12c, which will be 24 pi over 11. Times 15c, which is 30 pi over 11. And we can divide it by sine c, which is 2 pi over 11, 2c, which is 4 pi over 11, 4c, which is 8 pi over 11, and 5c, which is 10 pi over 11. Now we want to see, are they equal or not? Look, when we have sine 2 pi or 360 plus angle plus x, it will be equal to sine x. So 22 pi over 11 is 2, so, and we know another thing, sine pi over x equal to negative sine x, okay? So 12 pi over 11 is pi plus pi over 11, so it will be negative sine pi over 11 by using this rule. I told you the rules here, pi plus x, negative sine x. And if you want to learn all formulas in trigonometry, feel free to send message. My WhatsApp number in the description comments. Here it will be negative sine 7 pi over 11 because it is pi plus 7 pi over 11 times 22 pi is 2 pi over 11. So next one will be sine 2 pi over 11, and next one will be sine 8 pi over 11, because it is 2 pi plus 8 pi over 11. Now let's divide by sine 2 pi over 11 times sine 4 pi over 11 times sine 8 pi over 11 times sine 10 pi over 11. So we can cancel, let's see, 2 pi over 11, 8 pi over 11, 4 pi, and 10 pi. So, because some of them are equal, I told that when sum of two angles equal to pi, sine pi minus x equal to sine x. So here we can say sine 4 pi over 11 equal to sine 7 pi over 11, because some of them is pi, and also this is equal to this. We can cancel. Negative 1 times negative 1 is 1, so the answer is E. Okay, derivative and Lagrange multiply when you want to find maximum minimum of something. For example, in SMO 2022, we had two problems. In 2021, we had at least one problem. I released the solution of them and I solved with derivative and also Lagrange multiplier. Last year, before exam, I released a video. In that video, I explain exactly Lagrange multipliers, what is preparation for all three parts of SMO. You can use that. Let's go to next idea, binomial theorem. I solved these two problems with my previous video. I released the solution of SMO 2022. Now you can use binomial theorem and see that video. But here, let's solve also this problem from AMC. It says, what is the number of terms with rational coefficients among the 1001 terms in the expansion of this? Okay. So first, let me tell you, a plus b to the n is what? Binomial theorem. You say we have n brackets, a plus b, a plus times a plus b times, let's write times a plus b, n terms. And here you say, okay, if I want to select all of them, for example, no, the number of b is 0, it is a, n choose 0, n choose 1, 1b, so a n minus 1b, plus 2, n choose nb to that. Now here it says rational coefficient among this. So we know that when we have x, this plus y, this 1000, so it will be what? It will be the terms. 1000 choose I, x times cube root of 2 to the I times y times square root of 3 to the 1000 minus I. Okay. Now I know that I should be multiple of 3, so 3 should divide I, and 1000 minus I also should be multiple of 2. 2 divides 1000 minus I, so 2 divides I, because 1000 is even, so we conclude that 6 divides I. So I is 6k, and this 6k should be between 0 to 1000. And if you divide by 6, it will be from 0 to 146, 46 point something. So k is from 0 to 166, so 167 terms. Okay, and the answer will be C, the answer of AMC 12A Fall 2021. Okay, next one is two ideas for square root. When you see square root, there are two ideas. First one is to raise to the power of 2. Second idea is to use changing variable. For example, consider this one equal to 8, one of them. Here it is SMO 2022. I released a solution of this problem. You can see my video and see we use which of them. Okay, so these two ideas are important. Divisibility and modular. In these three problems, you should use that. Again, you can see my previous videos to learn them. They are related problems. Let's solve these two problems from AMC and then solve the next problems. So for this one, okay, it says the 6-digit number this is prime for only one digit a. What is a? If, let's check, sum of digits is 2, 2, 1, 5. If it is 1, then it will be multiple of 3. If it is 7, also it will be multiple of 3. If last digit is 5, it's multiple of 5. And now also let's consider mod 11. Look, if we consider mod 11, Let me tell you, mod 3, mod 9, sum of digits, mod 11. From right, you should consider plus minus, plus minus, plus minus. And another thing that is important in modular is when x, for example, mod something. For example, mod 2 or mod 7 is 2, and x mod 5 is 3. So there are two approaches to find that x mod 35 is what? Okay, if you want to learn that, as I said before, feel free to send message to my WhatsApp number in the description and comments, and it is important. Okay, mod 11, you consider plus minus, plus minus, plus minus. So it will be a 1, negative 2, negative 2, negative 4, plus 1, negative 3. So it will be a minus 3. And if it is 3, then it will be multiple of 11, so only e is left. Let's solve next one. It says the base 9 representation of the number n is this. What's the remainder when n is divided by 5? Because it is mod 9, you multiply this by 1, this by 9, this one 9 squared. But because we want to consider mod 9, mod 5, so we know 9 mod 5 is negative 1, okay? So we consider first one plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus. So 2 minus 7, negative 5, plus 6, minus 5, plus 2. So it will be negative 3, 6 minus 3, 3 minus 5 minus plus 3, which is negative 2, and negative 2 mod 5 is 3. So the answer here is D. Next idea is quadratic Vieta's formula Newton. Sum this problem. I release the solution of this. You can use that. Also AMC 12A 2022 I released in my previous videos. Also I released this one. And in all these three things you can use, you can see how Newton's sum is what, Vieta's formula is what, and quadratic equation and formulas are what. Important identities. Let me tell you, for this problem, let me write all important identities. 1, 2 to n equal to n times n plus 1 over 2. The first one, you should memorize these identities. Second one is 1 squared plus 2 squared plus 2n squared equal to is n times n plus 1 times 2n plus 1 over 6. Third identity is 1 cubed plus 2 cubed to n cubed equal to n times n plus 1 over 2 squared. Fourth identity is 1 plus r squared, r cubed to r to the n equal to rn plus 1 minus 1, r minus 1 on you, or you can negate both numerator and denominator. If r is less than 1, then we can say 1 plus r squared to infinity equal to 1 over 1 minus r. Okay, this one, and also as homework, it has a strategy, it has two approaches for reaching. Next one is r plus 2r squared plus 3r cubed to infinity. It is what? And if absolute value of r is less than 1. Fifth identity is hockey stick identity. You should memorize, which is, let me tell you, r choose r plus 1 choose r plus n choose r, n plus 1 choose r plus 1, and one problem of AMY 2021 can be solved with this. And for this problem of SMO, you should use this identity, a cubed plus b cubed plus c cubed equal to a plus b plus c times a squared plus b squared plus c squared minus ab minus ac minus bc plus 3abc. Okay. And you can see my video that I released the solution of SMO 2021. Next one, Casework and counting. Again, these two problems, I released the solution of them. You can use them, and let's solve this Harvard MIT Math Tournament 2023. And also, I released the solution of these problems. So let's solve this problem as last problem. Okay. HMMT 2023. Compute the number of ways to tile a 3 by 5 rectangle with one 1 by 1 tile, one 1 by 2 tile, one 1 by 3 tile, one 1 by 4 tile, and one 1 by 5 tile. The tiles can be rotated, and tilings that differ by rotation or reflection are considered distinct. Okay, so when you want to solve in casework problems, you should consider most restricted part. Now, can you tell me from these tiles which tile is the most restricted? 1 by 5. 1 by 5, how many cases do we have for 1 by 5? 3 cases. But if you place, two of them are same. Which of them? Top and bottom. So we consider one of them. And let me tell you, when you want to say this one and this one multiply by 2 and middle one, don't calculate this and then say, okay, mid 1. Try to write it simultaneously with this one. So we say this case and this case. Okay? It is so much important. Now, because when you have, for example, something like trees, you say, okay, we have two cases, this and this. Then we have two cases, this and this. So if you don't write this and want to calculate this completely, then come back, then you will forget, for example, in each step, what were the cases. So here we have these two cases. Now, after this, we should consider, let's focus on this part first. Which tile is better to consider first? 1 by 4. So if I consider 1 by 4 is here or this here and here. So we multiply by 4. And then here we should have 1 by 1 and 1 by 3 and 1 by 2. It has two cases, so 4 times 2, which is 8. So we've calculated this case completely. Now again here, 1 by 4 has 4 cases and all of them are similar. So we multiply by 4. Now, for this part we have two cases, 1 by 1 or 1 by 2. Now we consider again both cases, this part 1 by 1 or 1 by 2. In this case, we have 1 by 2. 1 by 3, we can switch two cases. Here we have 1 by 1, 1 by 3. Again, we have two cases. So 2 plus 2, 4. We can say 2 times 4, 8. 8 times 4, 32. 32 here and 8 here. Sum of them will be 32 plus 8, which is 40. So our answer for this problem is 40. And let's consider next one, a small example. You can consider this problem of SMO 2021 with the previous videos I released, and these two problems of AMC and BMO. For junior SMO, I released a video preparation for that review, junior SMO 2023. In that video, In that video, I solved this problem with exactly small examples. We can use that video to solve this. Let's solve this problem from BMO. It says for each integer, it's for British Mathematical Olympiad. For each integer n from 0 to 11, Eliza has exactly 3 identical pieces of gold that weigh 2 to the n grams. In how many different ways can she form a pile of gold weighing 2021? So here we say, okay, we have 3 from each of them. So we have 3 2 to the 0, or 3 1s, 3 2s, 3 4s, up to 3 2 to the 11. And we can consider that. Okay. Now we want to create 2021s. First, we want to see how many ways can we create 1, in how many ways can we create, for example, 2, in how many ways can we create 3, and so on. So here, if we want to create 1, it has 1 way. If we want to create 2, it is equal to 2 or 1 plus 1. 2 ways. So let's consider f of 1, for example, consider number of ways. 1, f of 2 is 2. If we want to create 3, 3 is 2 plus 1 or 1 plus 1 plus 1. So f of 3 is also 2. If you want to create 4, 4 equal to 4 or 2 plus 2, or you can say instead of 1, 2, 1 plus 1. So 3 ways. F of 4 is 3. Now we can guess the next one. 3, 2, 2, 3, 3, 4, 4. Let's check. 5 is 4 plus 1. Instead of 4, you can write 2 plus 2 plus 1. Instead of 1, 2, you can write 1 plus 1 plus 1. So we have 3 ways. F of 5, 3. We guess that next one should be 4. Let's see, 6. 6 is 4 plus 2. Instead of 4, you can write 2 plus 2 plus 2. Instead of 1, 2, you can write 1 plus 1. plus 2 plus 2. And here also, instead of 4, we can write 4 plus 1 plus 1. So 1, 2, 3, 4. So f of 6 is 4. Now we guess what? We guess that f of m, look, if m is even, it is m over 2 plus 1. Here it is. Let's check. I want to see, is it this one or this one? So f of 5 is 5 over 2. 2.52 plus 1, 3. So we guess the answer is f of m equal to m over 2 plus 1. So we guess, and then we should prove. F of 2021 equal to 2021 over 2 plus 1 floor of that. So it will be 1010 plus 1, which is 1011. Now we should prove this part. For proving this, you say, okay, f of we want to prove f of m equal to this. If we consider numbers, for example, it is even or odd. Okay, now let's consider, for example, if m is 2k, case 1, m is 2k. You want to create 2k. If you want to use 1, you can use 2 ones or 0 ones, for example, then the rest are something else. Then the rest can be 2 or 4, or all of them should be. Then you say, okay, if you divide all these numbers by 2, it will be some 1s, some 2s. So some of them here is what, 2k minus 2. So here, when you divide by 2, it is k minus 1. Because now you can use 1 to here. There are only 2, 4, and something else. Then when you divide by 2, you can have also 1. So you can say it is f of k minus 1 in this case. If you don't have any 1s, so some 2s, some 4s, and so on, it will be 2k. And when you divide by 2, it will be some 1s, some 2s, and it will be k. So we conclude f of 2k equal to f of k plus f of k minus 1. Okay, if I want to show you with example, look, f of 6, you have 2 ones in these two cases. And now, if you can see this part, 2 plus 2, you can divide it by 2. 1 plus 1, we've created this for 2. And this one, 4 divided by 2, 2. So these two cases are exactly for 2. That's the reason we say, okay, for example, when we have 6, when we have 2 ones, it will be what? F of k minus 1. And if you don't have ones, you divide by 2, it will be 1 plus 1 plus 1. And if you divide by 2 here, 2 plus 1. These cases are for 3. Okay? So f of 2k is this. Now for case 2, if m is 2k plus 1, then you have 1, 1 or 3 ones. Okay, if you have 1, 1, then the rest 2, something, 4. Then it will be 2k. You divide it by 2. It will be k. If you have 3 ones and some 2s, and so on, it will be 2k minus 2. So f of 2k plus 1 equal to f of 2k over to f of k plus f of k minus 1. And if we check, for example, f of 5, k is 2, is f of 2 plus f of 1. It's 2 plus 1, 3. Okay. Now I want to prove that it is m over 2 plus 1. So f of 2k, now I want to use induction. If you don't know induction, or if you want to learn important formulas in geometry, all important formulas that are necessary for senior SMO or other parts, AMC, any exam, feel free to send message or WhatsApp number in the description and comments. Okay, so f of 2k is f of k plus f of k minus 1 over 2. Sorry, f of k minus 1. By induction, I want to prove what? F of m equal to floor of m over 2 plus 1. We can say it is equal to k over 2 plus 1. And the next part is what? K minus 1 is k minus 1 over 2 plus 1. Okay, now for this part, k over 2 plus k minus 1 over 2. We can say what? I should prove why it is equal to. I can say something. I can say something. K and k minus 1, one of them even, one of them odd. So I can say k over 2 plus k minus 1 over 2. For the one that is odd, you have 1 minus 1 over 2, then plus 1 plus 1. Minus 1 over 2 minus 1 over 2, it will be cancelled with plus 1. So k over 2 plus k over 2 is k plus. And we proved it is f of 2k is this. Now, f of 2k plus 1 equal to f of k plus f of k minus. And if we use induction, it will be k over 2 plus 1 plus k minus 1 over 2 plus 1, which is equal to, again, one of them odd, one of them even. You can write k over 2 plus k minus 1 over 2 minus 1 over 2 plus 1 plus 1. Now, for this part, again, it will be k plus 1, similarly. Again, m over 2, this 1 over 2 is k plus 1 over 2. Floor of that is k plus 1. So we proved this problem. Okay, if you want to learn important ideas, important formulas, other important things that are useful in SMO, as I said, another exam, feel free to send message to my WhatsApp number in the description comments. Thanks for watching this video. Have a great day and bye.